Here we'll talk about reactions of aldehydes and ketones with Grignard reagents. This is an example of this type of reaction. This is one way to synthesize the medicine tamoxifen. This is an estrogen receptor modulator and it's used to prevent breast cancer. There are many applications of these types of reactions where we're adding Grignard reagents. But this is just one to kind of emphasize what's going on and the usefulness of it. If you look at the starting material and product, the difference in these structures is occurring right at the ketone. So this part of the molecule here where there's a ketone. You might notice this reagent that we're adding here, magnesium bromide, bonded. That magnesium is also bonded to a carbon structure or an organic structure. That carbon structure, in this case a phenyl ring, is bonded to the carbonyl carbon right here, and then the carbonyl oxygen becomes the OH group. And so that's really the pattern when we're looking at Grignard reagents. We add the organic part of the Grignard reagent to the carbonyl carbon. So let's look at a couple of reactions. Here's one starting material in the condensed formula. We can also draw this as a skeletal structure. We have an aldehyde at the end here, a CH, and that's bonded to two CH3 groups. So there's that structure there. Now I'm going to scooch this down real quick. When completing these types of reactions, we need an organometallic reagent. So an organometallic reagent has a metal and an organic part. So in this case, the magnesium is the metal for that example, and then that phenyl ring is the organic part. So we could add, we have our metallic part, and then we'll do this in pink to emphasize the organic part of the molecule. Let's say we have an ethyl group. So we call this an organometallic reagent. The organic part is a part of a molecule we have worked with a lot, our carbon chain, carbon and hydrogens. And then the metallic part is that magnesium bromide part of the molecule, but really the magnesium is a metal. Now the bond, we'll talk about this when we get to the mechanism, but this bond that I'm showing between magnesium and carbon is an ionic bond. It has some covalent character, but that is what makes this molecule, this reagent, reactive towards nucleophilic addition. So we'll get to that when we get to the mechanism. If we add this reagent, we first add it with an ether, so a polar protic solvent. In the example up here, they have THF, which is tetrahydrofuran. That is the 5-membered ring ether. So we have an oxygen bonded to 2 carbons, and those are part of a ring. So we need some ether. It could be THF, it could be diethyl ether, whatever's available. And then we need to add an acid, so we'll just say H3O plus for the second step. Then the final product here, we are adding the organic part of the organometallic reagent to the carbonyl carbon, and the carbonyl oxygen becomes an OH group. So the final product looks like we still have our 2 methyl groups, we still have our CH, and then the carbonyl carbon is now bonded to the methyl group from the organometallic reagent. And then the carbonyl oxygen is now an alcohol group, and this hydrogen for the alcohol comes from the acid in the second step. So the reason why these reactions and organometallic reagents are so useful is that we are creating a new carbon-to-carbon bond. And that is really useful in industry. We can extend molecules to be much larger, longer carbon chains. And a lot of the reactions that we've talked about so far, especially for aldehydes and ketones, we're not adding a new carbon-to-carbon chain. We're adding an alcohol group or an alkoxy group, something like that. So using these organometallic reagents allows chemists to create a new carbon-to-carbon bond, which is extremely useful. So that's one new part of the molecule. And then the other new part is forming this alcohol. And then with forming the alcohol, creating that new carbon-to-carbon bond, the carbonyl carbon is reduced. Just like our reduction reagents, our reducing reagents. Before we get into the mechanism, let's just do one more example to really emphasize what the reaction scheme looks like. So we'll do, let's say, acetone. Skeletal structure shown right here. We're going to add magnesium bromide. Magnesium's bonded to the bromine and to the carbon chain. And we'll just add a propyl this time. We need some sort of ether in the first step with the organometallic reagent, and then an acid in the second step. And then our final product, we've got our carbonyl carbon still bonded to two CH3 groups. The carbonyl oxygen becomes an alcohol group, and the carbonyl carbon is now bonded to the organic part of the organometallic reagent, so a new propyl group. We could draw this as a skeletal structure, just like that. All right, so here are 3 examples of reactions with Grignard reagents.